3405 minus summation of x 32 summation of y times 1105 over square root n is 6 times summation of x squared 220 minus summation of x, which is 32 squared, put the bracket, times with n is 6 summation of y squared minus summation of y squared, and use calculator and round it to 3 decimal digits. Here's 8, so you round up, so get negative 0.883. And then and this one, that's the r, negative 0.883. Step 4, conclusion. The linear correlation coefficient r equal negative 0.883 is closer to negative 1. Negative, so it's a negative, so suggests a strong negative linear relationship between the number of years an alumnus has been out of school and the amount of the alumnus's contribution in dollars. That is, the more years an alumnus has been out of school and the less amount of the alumnus's contribution, because it's a negative linear correlation between it. Question 7. Test the significance of the correlation coefficient r found in the question 6. Question 6, we find r is negative 0.883, and we are going to test this one, this number r, the significance. Alpha equals 0.05. First step, hypothesis. R is for the sample correlation coefficient. For population correlation coefficient, we use rho represent. So null hypothesis rho equal 0. Alternate hypothesis rho not equal 0. We will test this. Equal 0 means no relationship. If equal 0. If not equal 0, then have a relationship. Positive is a positive linear relationship. If a negative is a negative linear relationship. Step 2, find the critical value for alpha equal 0.05. Degree of freedom, we use 6 minus 2. It's not just minus 1, it's minus 2. 6 minus 2 equal 4, because it's 2 of it for the x minus 1. For the another y also minus 1. Total 2 number, because given 2 column data. So given 2 column data, degree of freedom for this is minus 1. Degree of freedom for this also minus another 1, because given 2 sets of the data, so minus 2. So n is 6 minus 2 get 4. So degree of freedom is 4. And from use, because test value, you will use t-test. So here use t-table. T-table, degree of freedom is 4. And here is a 2 tail, because it's not equal. H1 is not equal. Degree of freedom is 4. Alpha, it's given here is 0.05. Two tail. Alpha equal 2 tail, 0.05. Degree of freedom 4. Intersection here, which is 2.776. Positive and the negative, because 2 tail. So one is 2.776, another one is negative 2.776. 0.05 divided by 2. So each tail, right tail, this area is 0.025. Left tail, this area also 0.025. And the t value is equal R. R is from the question 6. We figure out is negative 0.883. R use negative 0.883 times square root of n minus 2, which is degree of freedom 6 minus 2, over 1 minus R is a negative 0.883 square. And use calculate figure out, we'll get 3 decimal digits, negative 3.762. Then compare with critical value, negative 2.776. Test value, negative 3.762 is less than negative 2.776. So it's to the left of test critical value. Is a test value. Test value is falling in the critical region. So we'll on this side is suppose H1. Between is suppose H0. So we'll fail to reject will reject H0. This is H1. This side is H0. So falling in critical region. So we'll reject the H0. Reject H0, which is H0 is rho equals 0. Rho equals 0 means no relationship. So reject no relationship. So there has linear part, which is negative, because R is negative. So your answer. So result. There is a significant negative relationship between the number of years an alumnus has been out of school and the amount of the alumnus's contributions. Question 8. A. Find the equation of the regression line for the data in question 6. B. Predict the amount of an alumnus's contribution if the alumnus has been out of school for 4 years. So find out the linear regression line. We need to figure out B0 and use this formula. In this formula, needs summation of y, summation of x squared, and those come from question 6. Question 6, we already have those data on that question 6. So from question 6, we the value needed for the equation are, from question 6, we have n equals 6, summation of x is 32, summation of y, we have summation of xy, summation of x squared, which is from question 6, this table, we figure out. Then plug into the formula, B0. B0 is y-intercept, plug in. Summation of y is 1105. Summation of x squared is 220 minus summation of x is 32. Summation of xy is 3405 divided by n is 6 times summation of x squared is 220 minus summation of x is 32 square. Plug in. Then we'll figure out is 453.176 rounded to 3 decimal digits. Round up. That's B0. Then figure out the B1 because the linear regression line. Linear regression line is the formula is y hat equal B0 plus B1x. So we need to figure out slope B1. And this is a slope formula. And it's also come from the question 6, that table. N is 6, summation of xy, and summation of x, summation y, and plug in. Denominator is the same as B0. B0, B1 have the same denominator. Plug in to the formula, and you will get is negative 50.439 rounded to 3 decimal digits. And then plug into linear equation formula y hat equal B0. B0 is 453.176 plus B1 is a negative 50 minus 439x. And then further simplify. You got 453.176 minus 50.439x. Get the linear regression line equation. And B, question S, if I graduate from school for 4 years, so X use 4, plug in into this equation and figure out the contribution is $251.42. For dollars, for money, always 2 decimal digits. Rounded to 2 decimal digits for dollar. Question 9. Use the regression coefficient R equals 0.75 to find the coefficient of determination and the coefficient of non-determination. Explain the meaning of each. The correlation coefficient given in this question R equals 0.75. The formula for the coefficient of determination is R squared. So it's 0.75 squared, get 0.5625. And explain the meaning of this. So means move decimal point to the right 2 decimal digits, attach percent sign, and change 0.5625 into percent. It's about 56.25% of the variation of y can be explained by the linear relationship between the 2 variables of x and y. Between the 2 variables x and y. And what is the coefficient of non-determination? Formula is 1 minus r squared. Is 1 minus 0.75 squared. So it's 1 minus 0.5625. Get 0.43.75. And move decimal point to the right for the 2 positions. And get 43.75. Attach percent sign. So it's about 43.75% of the variation of y cannot be explained by the variation of x. Question 10. Consider the data in question 6 and 8. Compute the standard error of the estimate. So estimate, S means standard deviation of here is the standard deviation, we call standard error of estimate. The formula is the square root of summation y minus y hat square over degree of freedom n minus 2. Equal another formula. The two formulas are equal. Summation of y square. So we need summation of y square, summation of y, summation of xy. So you go and we need b0, b1. So from question 6, you can get summation of y square and summation of y and the summation xy. From question 8, b0 is 453.176. b1 is negative 50.439. You can get from question 8 and get b0 and the b1 and plug into this standard error of estimate, the formula. Summation of y square from question 6 get 364525 minus b0 from question 8, 453.176 plug in, times summation of y is 1105 minus b1 is negative 50.439 times summation of xy is 3405 over n minus 2, degree of freedom, it's 4. Take square root and get 94.22. 94.22 estimate. You can add one more, either one. 3 decimal digits. This is a standard of estimate, standard errors of estimate. If you want, you can go 94.221. And hence, the standard deviation of y is observed value and about the y hat is a predict value, y minus y hat. Y is observed value about the predict value, y hat, is 94.22. And since this is a dollar, actually this is a contribution y is in dollars, so you can just leave answer with 2 decimal digits. It's okay. 2 decimal digits for dollar is 2 decimal digits. Because y is contribution is how many dollars. That is chapter 10. The next is chapter 11. Chapter 11, we will use chi-square test for goodness fit formula. Is chi-square equal O. O is observed frequency minus E. E is expect frequency. Square divided by E, expect frequency. Degree of freedom is k minus 1. K is the number of categories. Another, this is good of fit. Another one is a contingency table for independent and the homogeneity of proportion. They all contingency table. This use contingency table for the independence and the homogeneity of proportion. Use this formula. It's the same formula, chi-square formula. Same as good of fit formulas. But this one is only one, and this one have row and the column have 2 sets of the data. Goodness of fit have 1 set of data. This test whether they have a relationship. And this one have 2 sets of data. Test whether the 2 sets of data is independent or dependent, or test for the homogeneity of proportion. and two sets of data. Degree of freedom is row, number of row minus 1 times number of column minus 1. Expected value will be row sum times column sum divided by grand total. We use the two formulas. Question 11. A food service manager read that the place where people consume takeout food is distributed as follows. Consume the takeout food at home is 53%, in car is 19%, at workplace is 14%, the other is 14% also. A survey of 300 randomly selected individuals show the following results. And at alpha equals 0.01, can it be concluded that the distribution is as stated? So from this is the sample. They want to test this sample have the same percentage as the stated. So null hypothesis is takeout food is consumed according to the following distribution, which is 53% at home, and 19% in the car, 14% at work, another 14% at other places. And one test, the distribution as stated is H0, which is the claim. So H1 is distribution is different from the stated in the null hypothesis. H0 is stated and want to test whether it is as stated. So H0 is the claim. And then we are going to test, use goodness of fit, the formula. So we will use this chi-square. Chi-square equals summation observed. So use this formula. So we will use chi-square table and find the critical values. For the degree of freedom, since there are home category, it's at home, in car, at work, and others. 1, 2, 3, 4. 4 category. Degree of freedom is 4 minus 1. It's 3. And the question say alpha equals 0.01. Now for chi-square curve, and alpha equals 0.01 totally to the right tail. Don't divide it by 2. The critical values, it's we look at the chi-square curve, chi-square table. Alpha equals 0.01. Degree of freedom is 3. Then intersection is here. Is this one? Is 1.345. That's critical value. Compute the test value. We need to figure out expect E. The expected values are found by multiply by total number of shopper surveyed is 300 by the percentage of the people in each category. So 300 times 53% at home, tying together is 159. So for home, observed is 142 individuals. Expect is 159. And for in-car, observed is 57. And since 19% in car, so it's 19% times 300, got 57. So we got 57 and put it in is expect in car. At work is 14% times 300 is 42. So at work, observed is 51. Expect is 42. And for other type, it's 50. Observe is 50. Expect is 14% times 300, also it's 42. And create this table. After create table, then we figure out chi-square. Chi-square equals summation, parentheses, observe 142 minus 159, the difference, squared, divided by E, expect 159, plus the two difference, 57 minus 57 squared, divided by 57. Then 51 minus 42, the two difference, squared, divided by expect 42. Then 50 minus 42, difference, squared, divided by expect 42. And use calculator, round it to 3 decimal digits, and get 5.270. And for this chi-square, critical value 11.345. Alpha total go to the right tail. And 5.270 test value is less than 11.345 critical value. So it's to the left of critical value. So it's in H0. And so this is suppose H0 fail to reject H0, fail to reject null hypothesis. And the claim, what is the claim? The claim is for H0. The claim is H0. So this is a fail to reject H0. So there is not sufficient evidence to reject the claim that the distribution is as stated, because the claim is H0 null hypothesis. We fail to reject it. So it's not sufficient evidence to reject the claim. Question 12. A survey was conducted on how a lump sum pension would be invested by randomly selected 45-year-olds and randomly selected 65-year-olds. The data are shown. So here two set of data. The data are shown here at alpha equal 0.025. Is there a relationship between the age 45 and age 65 and the age of the investors and the way the money would be invested? So large company stock fund or small company stock funds, international stock funds, or CD or money market funds, total four way of money four ways investment. The other one, bond, have 1, 2, 3, 4, 5 ways, total 5 ways of investment. So here has a two row. Age 45, invest as large money stock funds, has as 20. How a lump sum pension would be invested. And the question asks you, age in the age of investor and the way the money would be invested, the wage of the money invested. So how a lump sum pension would be invested. So for age 45, large company stock funds is 20. Stock funds 20. This is 10. So step 1, state the question asks you, is there a relationship? So for H0 is the type of investment is independent of the age of investment, independent. And the H1 is the type of investment. Those are type of investment is dependent on the age of investment. The question asks you, is there a relationship? Whether have a relationship, and that is the claim, is dependent on the age of the investment. So that's H1 is the claim. Step 2, find the critical values. The degree of freedom is R minus 1 times C minus 1. R is a row, 2 minus 1. C is a column, 1, 2, 3, 4, 5. 5 column, 5 minus 1. So it's 1 times 4 equal 4. Degree of freedom is 4. And question say alpha is 0.025. So since here we use critical test value, use this formula, chi-square formula. So we will use chi-square table. And alpha equal to 0.025. And totally go to the right. Degree of freedom is 4. Alpha is 0.025. So will be here. 4. Degree of freedom is 4. Alpha is use chi-square table, chi-square distribution table. Alpha is 0.025 intersection, and we'll get 11.143. That is the critical values. So if you draw chi-square curve, this is alpha 0.025. Total go to the right tail, and this critical value is 11.143. Then figure out the test values. We will use test value. We'll use this formula. O. Those are all question already given. Those are observed data. 20, 42, 10, 24. Those are observed data. And we need to figure out E. And how to figure out E? And use this formula. E, expect value, is equal row sum times column sum over grand total. Now row sum is 20 at the first row, 20 at 10, add 10, add 15, add 45. First row sum is 100. And the second row, 42 times add 24, add 24, add 6, add 24. Second row sum is 120. And this 100, add 120, add together. And this is the grand total, 220. Column sum is first column, 20 add 42 is 62. 10 add 24 is 34. Third column, 10 add 24 is 34. And 15 add 6 is 21. That's column sum. So here is the column sum, here is the row sum. And figure out first row, first column. This one is on the first row, first column. how to figure out the expect value is row sum times column sum divided by total. So here 100 times 62 divided by 220 and got 28.18 and put in the parentheses. And the first row, second column, this data expect value, it's 100 times 34 divided by 220. So here, 100 times 34 divided by 220, got 15.45 and put it in this position in the parentheses. So use this way, keep going on until the last one. The last one, this one, is going to be 120 times 69 divided by 220, which is this one, get 37.64, and put it in this parentheses. So each 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, total 10. We then figure out, complete this table. Then you do observe, like 20 minus 28.18, the difference of the two numbers, square it divided by expect value, 28.18. Add the difference of the two numbers, observe and expect, difference squared, divided by expect, 15.45. And keep going on until the last one is a difference, 24 minus 37.64, square it, divided by 37.64, the last one. And then those total 10 terms, use calculate, figure out, is equal 27.933. Round it up, round to 3 decimal digits. 27.933 is greater than 11 point critical value, 11.143. So it's fall to the right. So to the right of critical value is greater than. So it's falling in the rejection region, critical region. So this will reject H0, support H1. So you will say, reject the null hypothesis and summarize the conclusions. Since claim is with H1, so this is sufficient evidence to support the claim that the type of investment is dependent on the age of investor.